Am I in the frame? Good. Straight on the stream here. Thanks for coming, everybody. How's it going? You can build some cool. Thanks, Linda. Linda gets it. Linda gets it. Yeah. Her last name's Getz. Are we good? Streaming. How many folks here have blockchain experience already? Come on, everyone does. Yeah. Good. That's good. Emily, where is it? I think maybe adjust the gain a little bit, please. David, what's up? Are we live? Oh, everyone can see me. Oh, hi. We're live. Hey, I'm Kyle Thomas, founder of Provide. We're here to kick off the hackathon, EthAtlanta 2021, sort of a hybrid event. We have a really good turnout here at Atlantic Tech Park. We've got a bunch of developers here. And you can also join the hackathon virtually and build a project this weekend and submit it and also be eligible to win. We have a bunch of awesome. Hey, David, just click. Oh, there we go. That's me. All right. So there's some rules for the hackathon. There's also an email that went out. If you're registered, you should be able to. Emily, the gain may be slightly too high now. Yeah, it's good. Yeah, we're good. That's okay. We're good. Okay, so there are some rules. Basically, they are, they're pretty standard. Don't be an a-hole. Don't be a racist. Have fun, and that's the gist of it. The EF has given us the access to 20K in funding, up to 20K in funding for bounties. Provide's gonna do 4 or 5K worth of bounties. What else? Oh yeah. All the bounties are at the discretion of the funding organization. So EF, that means the EF does not have to bounty or actually award all 20K that's been allocated. Yeah. So there's some criteria for your projects. Your vision, like is the thing useful? Is there like a good potential for some product market fit with the submission? Does it work? What are you doing? Thanks, David. Does it work? The PowerPoint slides do. They're good. That was bad. And does it perform well? Is there a good intuitive user experience? That's also a criteria. And really, I don't know if you can see this from YouTube, but is the thing novel? That's pretty important, I think. Ultimately, the judging is going to happen Sunday, and it'll just be the discretion of the judge at the discretion of the judges to evaluate the project submissions using this criteria. But there's no like guaranteed point structure around this. It really is just going to be at the discretion of the judges. However, I would certainly build something awesome that works, and that will increase your chances, and also if there's potential for product market fit. And of course, does it use the Provide stack? Hugely important. Just kidding. You can actually use any stack you want to build a project. And yeah, but again, just to remind you, the bounty awards are at the discretion of the funding organizations. Click. Oh, there we go. All right. So there's a bunch of websites or links rather. The bounties that are listed. You're going to want to submit your projects via a web form. That way, we can begin to evaluate them early and often. So as soon as you have your team and your concept, and sort of figured out, please submit it so that we can get it on our radar and coordinate logistics for presentations on Sunday morning when judging happens. So yes, you must submit the project through that bit.ly URL to be eligible for any of the bounties and to be eligible for presenting Sunday to the judges. There's a Discord. I would recommend joining that, and you can get help. You can get some tech support from various folks like Provide and Consensus and others who are in the community Discord. What else? That may be it. Does anyone have questions around the hackathon yet? Any questions? Oh yeah, your team size should be 4 people or less. That's one of the other rules worth highlighting. But otherwise, yeah, any tech stack, any idea should be good. No. What's the other tech stack that you would consider? Provide is an open tech stack as well. What's the other stack that you would use? The what? Oh yeah, okay, got it. Yeah, sure. Well, you can use the so Provide does have our stack is open. You could certainly use that. You could use an open stack. I think the big benefit will be just how much stuff is done for you out of the box. So your project can just start building sort of application level functionality. And also, Davin's going to cover some of this in his talk here in about 15 minutes. But yeah, I think it's really, there's like a, what do we call it? The no knowledge, zero knowledge API, which you can sort of use out of the box. Yeah, there's a lot of advantages, I think, to having sort of a head start. Thanks for the question. Anybody else? No. No. Trying to what? Get on there. Yeah. I don't think we have any more questions. Are there any questions on YouTube, from YouTube? All right. Maybe that's very clear. Thanks to all the sponsors that help make this happen. Lots of awesome sponsors here. Yeah. Nat Sky. What's up, man? Okay. Well, in that case, we can take a pause, and Davin's gonna present on the Provide stack in about 15 minutes. It's right there. Yep. It's in the email too, went out.
All right, guys. Huh? All right, folks. If everybody would take a seat, we'll get started again here real quick. And I do want to say there's a good number of us here today from the Provide team. If anybody has any questions about the tech stack or kind of anything we go over today, let us know. Provide team folks, raise your hand, please. Everybody. There's others. They're shy. They're not raising their hands. Mr. John Walpert. Mr. John Walpert, could I have your attention, please? Pardon me, Mr. John Walpert. Hey. Hi. Hey, guys. I'm David Jones. I head up product at Provide. And we're going to take a look today at building with the Provide stack. We've really tried to make it as easy as possible. Hold on, let me fix something. I was just trying to get you to quieten down out there. There we go. All right, so like I said, we try to make it as easy as possible to build with the Provide stack. And it starts with our 4 core services. And we have actually open sourced these very recently. And they kind of contain everything you need to really build something off of our stack, to build on a distributed network, to kind of do anything you need to. However, it is very well suited for the baseline process, the baseline protocol process, and we'll go over that in just a minute. But the 4 core services that we have open sourced are Ident, and that's an identity management service. Then we've got Vault, and that is a key management service for managing keys and secrets and things like that. And we've got InChain. It's kind of like a distributed network switchboard. It gets you where you need to go, gets the information where it needs to go. And then we've got Privacy. That's, as Kyle mentioned, our no knowledge, zero knowledge service. It really makes working with zero knowledge circuits and things like that really simple, exposes a real simple API, and we'll go over that. All right, identity management. So with our service, we've got applications, and that's just like a bundled group of resources that users and organizations can use to do whatever it is that they need to do. And built into that, we have authorization and authentication via JWT tokens that each of these can possess, and that gives them the permissions to do the things that they need to do. It kind of gives them access to the applications they need to access, the other processes they need to access, so on and so forth. And here's a real quick example of participant management. This is how our Ident service is used along with a couple of our other services to organize an org registry for the baseline process. In this example, Alice is inviting Bob to a work group. So their organizations actually go and update an organization registry, and that is all using our Ident service, our InChain service, and our Vault service. All right, vaults are handy for managing keys and secrets and HD wallets that you may use in any of the processes that you're using our stack for. The keys, we've got a couple different keys here. It supports a lot more keys than that. They'll all be listed in our documentation a little bit later when we release you guys to the house to kind of go build what it is you want to build. We've also got secrets baked into vaults. Now, secrets can hold arbitrary data, anything you want to throw in there. We've got an encryption endpoint to let you encrypt whatever it is you're putting in your secret. And then, of course, you can retrieve it whenever you need. Privacy, this is the cool one. This is the no knowledge, zero knowledge service. And what we do is we take zero knowledge proofs, thanks to Myra here, and we expose an API that makes it very simple to use them. Essentially, this entire process here It's the life cycle of zero knowledge proof. You would have to create that process on your own. And I don't think there's very many people that can really do that. So we made this API, we expose the endpoints for it, and you can do all this via our service, privacy, and we did open source that to make life easy on everybody. There's a good chance you'll be using this if you're hacking with our stack today or this weekend. So do get to know it. It is pretty complicated, and we've included everything we can in the documentation. And again, if you have any questions, feel free to hit one of us up or ask questions in our Discord server. In-chain, this one's really cool too. In-chain kind of takes whatever input you give it, and it routes it to the correct distributed network. And it can handle things like accounts, connectors, contracts, networks, oracles, tokens, transactions, wallets, bridges, not listed there, a couple different things. But it's essentially the switchboard that connects what you're building to all the distributed networks out there, as long as you set it up and get the integration running. But yeah, it'll work with everything in our stack natively. Kind of anything you pass into it'll go where you want it to go. It's really handy. And there's two different services within in-chain. There's a stats daemon and another one. I forget the name of it, but they will both listen for events coming in and monitor the health of all the networks that are out there. Reachability daemon, thank you. All right, and like I mentioned earlier, our stack's really handy for working with the baseline protocol. It just ended up that way. It wasn't built specifically for the baseline protocol. We have kind of tweaked it to help sort of match the processes within the baseline protocol. But so we've got our standard stack here, IDENT, in-chain, privacy, vault. And then NATS, Postgres, and Redis down there, those are microservices that kind of live under our stack that say NATS handles a lot of the messaging between services. Postgres and Redis do a little bit of work back there too. But then all we have to do is tack on this baseline integration proxy here. And what that does is it connects our stack with your system of record and kind of takes all these pieces and puts them to work for your system of record via that baseline proxy, and then dumps anything it needs to out to the connected EVM or whatever network you may have configured there. And to kind of go over some of the things that might be fun to build and to help everybody understand kind of what pieces are involved, where things fit, we're going to look at a couple things that you could build. So here we've got, this is an example of a connector. A connector just takes the provide stack and connects it to some endpoint, something that you need to connect to. In this instance, we're looking at a system of record, SAP. And the baseline proxy is actually a connector that we have built. It's in-house, it's not open source. However, it connects our stack to that system of record, handles everything it needs to, and really makes it a seamless kind of experience when you're working in that system of record. There's no need to kind of go back and forth. You just use your system of record like you normally would. And then that connector and then our stack does everything else for you. And examples of connectors that need to be built that would really help to kind of boost the ecosystem, or any other, say, systems of record, or any other services that may benefit from baselining. Again, so another example here is connecting different networks to our stack. Right now, we support most of the Ethereum testnets. We support Ethereum mainnet. We've got a couple different announcements coming out. We support Base Ledger. I believe we've just added a integration for the Open Permission Ethereum network. So building additional network integrations into our stack is really helpful in sort of expanding the capability of the stack itself and what you can do with it. And kind of along those same lines is adding bridges to things and adding functionality that can take in information and distribute information as necessary to whatever process is needed. In this example, we're looking at a Chainlink oracle. Building an integration with that through our stack would be really helpful, say, in a baseline process where you need to verify or just know that the data you have is correct. That's a really valuable one. I do think we will have a bounty for that. There's a couple of these are related to bounties. So when you go look at the docs and you take a look at the bounties, Some of them will be very similar to these. All right, and the tools you can use to build those things. The provide CLI, it's a really simple to use CLI that kind of lets you use all aspects of our stack. It's even got, so the baseline proxy is built into it as well. So you can even interact with a baseline instance. You can send workflow messages, baseline, kind of whatever you want through the CLI. It interacts, you can create vaults, users, organizations, applications, work groups, workflows, anything you want to, you can build through our CLI. Tunnels, now this one's kind of hidden, and we have given you guys a freebie for this event. Tunnels is, it creates an end-to-end connection between, two services that are running, and normally you'd have to tweak a firewall to make that work. And Tunnels is built into our CLI, and it handles that for you when you are sending messages back and forth. So yeah, that's another great tool to use, and again, it'll be built into the CLI over this weekend, a little freebie. Postman, I'm sure you're all familiar with Postman. We've got a collection out there. Snag it, learn the endpoints, learn the request. It's really handy. It'll help to explain a lot of things if there's any fuzzy areas. And then, of course, we have language-specific support libraries. There's a good number of them. I think we've got most of the popular ones, I'm not sure. And they're all working. They're all up to date. So if you need to use those, they'll be included in the documentation for the hackathon guide this weekend, too. And this is a quick screenshot of our CLI in action. It's really simple to use this thing. We have really tried to make it as easy as possible. And in this example, we have somebody creating a user, Johnny Young at provide.network there, and then authenticating that user, and then creating an organization and a vault for that user within that organization. And from there, it's a couple more commands, and then you're baselining messages. It's really that easy. We do have a Discord server set up, both for this weekend and beyond. So if you need help, have questions, do hop in there, give us a holler. When the bounties are all posted, there will be a project lead for each bounty. If you can, reach out to that project lead if you're working on that bounty via Discord, and they'll be able to help you. And that's what I got, folks. I believe the documentation has been distributed. Have we put that documentation out there yet, Kyle?
Right.
Okay, it's my job apparently. Then we have not. We'll get it out right after this. And then again, if anybody has any questions, please join the Discord server, let us know, or ask us in person.
So
any questions, anybody?
I think there's a few things. Did you touch on the CLI?
Yes.
Okay. So the privacy service uses NARC, which is an open source privacy utility. That was a question that was just asked. I think it's important to know that. Yeah, if you, there's a lot of folks from Provide here that can help, and also on the Discord, there's people there too. There's some really cool art back here. There's like a miniature NFT gallery. Shout out to Jack for setting that up. You guys should check that out. It's pretty cool. What else? Guess we'll talk about BS. We'll talk about BSN. We'll get Tim Bailey on from BSN here at I think 1:15. So, all right, cool.
All right. Any questions other than what Kyle just clarified up here? Cool. All right. Thanks, guys. We will be back on in what time? 1:15.
Did you go over the battleship?
Not yet.
I would. Okay. Yeah, you might want to cover that.
We will. Thanks, guys.
Okay, guys, we're gonna Tim Bailey, VP of Global Sales from Red Date Tech, is going to talk about. Hey, so this is a little echoey. This room is a little bit echoey. We can hear everything up here. Tim Bailey, VP of Global Sales from Red Date Tech, is going to talk about baselining BSN using the open permission Ethereum network. If you guys are interested in learning about some awesome stuff that's coming out of Hong Kong, now would be a good time to check that out. Hey, Tim. Hey, Tim.
Hey, Tim, can you hear us?
Yeah, I can hear you there, Kyle. Can you hear me okay?
No.
Kyle, you there? Hello? Hey, Kyle, can you hear me? Sorry, Kyle, I'm gonna wait for your cue.
Just 1 second. We're working on the audio here for Tim.
Test. Testing. Test 1, 2, test. Testing.
Virtual cards and organize them the way you want. DigMe gives you control of your data, keeping your personal details private and letting you share it with people you choose. So whether you're sharing it with a DigMe user or a non-DigMe user, anyone can download your business card when the device broadcasts the data to the phone with ease.
Test. Testing. Test.
Hey, there we go. We hear you, Tim. Okay, guys, we have Tim. Sorry about that. I blame David. Okay, Tim, go for it.
Testing. Okay, great. So Kyle, I heard your message that you can hear me. I'm just gonna
Tim's
keep
on.
going here.
We got Tim. Sorry about
So
that.
this is Tim Bailey. I'm from Red Day Technology. I'm based here in Hong Kong, and it's a little after 1:20 in the morning here. So I'm going to keep my remarks pretty brief. First of all, I want to thank Kyle and the Provide team for having us here. We're proud to be sponsoring the event today and over the weekend. So I'm going to talk a little bit about the blockchain-based service network, or BSN, and then also open permissioned Ethereum. So at Red Day Technology, we believe that, like many of you in the audience there, that blockchain technology has the potential to dramatically change the way that businesses operate and provide services, and the way that developers can build applications. But we believe that there are two core fundamental issues standing in the way of mass adoption of blockchain. The first is cost. It's still relatively expensive to purchase cloud resources, create a development environment, build applications, build a network, and deploy those applications. And so one of the big focuses for us is to lower the cost of developing blockchain applications. We want the cost to go down to the point where a university student in her dorm room who has a great idea for an application or a service can go ahead and build that, and doesn't have to spend $5, $10, $20,000 to go do that. So cost is a big focus for us. The second one is interoperability. There are over 100 different blockchain protocols out today, and one of the big issues is compatibility and interoperability between the different chains. So that's another big area of focus for us, is making it much easier for different chains, whether they're permission chains or permissionless chains of different protocols, to be able to interact and exchange information. So for us, we really think that blockchain technology is kind of where the internet was in the early 90s, when it was still very expensive to build a website. You had multiple competing standards and interoperability issues. And it wasn't until the cost of developing websites came close to zero, and you had common standards like TCP/IP and HTTP, that the internet really took off. And so we believe that those fundamental aspects need to be in place in order for blockchain to really take off. And that's what really prompted us to create the BSN. So the way to think about us is we're really an integrator. We've integrated all the different public cloud services, AWS, Google, Azure from Microsoft, as well as some of the big cloud providers in China like Baidu and China Mobile. The next thing we did was integrate the blockchain protocols themselves. So we've integrated most of the key global permissioned blockchain protocols like Hyperledger Fabric, Hyperledger Besu, Quorum from Consensus, Corda R3, as well as some of the big permission chains in China like Fisco BCOS. Next, we integrated the most popular public chains, obviously Ethereum, but also EOS, Algorand, Tezos, Oasis. And then finally, interchain services. So Poly Enterprise and Arita are two of the interchain services. And we continue to, on a quarterly basis, integrate more blockchain protocols and interchain services into our infrastructure. So this is kind of a technical diagram of the BSN. At the bottom, you have that cloud service layer that I talked about with on the different public cloud providers. And then we have what we call the public city node layer. And the way to think about public city nodes is they're really virtual data centers that sit in a public cloud environment. We've built about 140 of these virtual data centers to build out our global network. Each of the virtual data centers or public city nodes contains, integrates all the permissioned blockchain frameworks that I talked about, all the permissionless frameworks, as well as tools to make it easier for developers to build applications such as IDE services, testnet services, etc. We also have integrated a type of blockchain protocol that we call open permission frameworks. And within China, as an example, I think we've all been reading the news lately that cryptocurrencies are banned by the government in China. So we needed a way for permissionless chains or public chains to be able to operate legally in China. So we created an initiative we call the Open Permission Blockchain Initiative, where we work together hand in hand with permissionless chains and help convert them into versions that can operate legally inside of China. And then in the top layer there, we have what we call the portal layer. So we're working to build a network of partners around the world who will build and operate blockchain as a service portals, which is the way that developers will get access to the BSN resources in order to be able to build and deploy applications in a much more cost-effective way. So now I want to talk a little bit about an initiative we call OPE, or Open Permission Ethereum. OPE is a public Ethereum blockchain network that's hosted and maintained on the BSN and is available to global users. Right now, it is the only legally compliant way that an Ethereum application can run in the China market, which is obviously very important for developers because it's the world's fastest growing economy, and is a country and a market where blockchain technology is widely accepted and being embraced by both businesses and the government. OP is fully compatible with the Ethereum network, but different from the public Ethereum network in that the OPE blockchain has a different Genesis block and a specific network ID. Kyle, in a couple of minutes, I'm going to hand it over to Kyle, and he's really going to show you the open permission Ethereum in action, and it will be a key part of the hackathon today. And I would encourage you, if you have questions afterwards, after the event, you can reach out to us at inquiry@reddatetech.com. If you got questions about open permission Ethereum or want more information or engage us in a dialogue, we'd love to hear from you. So hopefully you're able to hear me okay. I can't hear you guys there, but I'm excited. I'm excited about the event, and Kyle, I'm going to hand it over to you now.
Sure.
Thanks, Tony.
Yeah. All right. Yeah. So OPE is a pretty big deal, and we've been working with Red Date for informally for some time. We have integrated BSN to provide. You can use the BSN network to the OPE network rather to baseline, and if you download the provide CLI, it's open source. You can grab the provide CLI. That's what it looks like. If you, after you've installed it, you just need Golang. And once you've installed the provide CLI, you can create a baseline workgroup. Let's call it EthATL, workgroup EthATL, OPE, BSN OPE project. All right. So then you have to select the network. Here, let me start over here because it's, you can see a little better. EthATL. So you select a network. We've got support for these Ethereum networks, these public networks rather, Base Ledger and the BSN Open Permission Ethereum network. If you select that and you have an organization, it will deploy a baseline workgroup for you on the OPE network, which is the legally compliant network in mainland China. So this is a really big opportunity for developers to tap into this new opportunity. You see that is the transaction hash that's been deployed to the OPE network. Provide is sponsoring a $1,000 bounty for anything built on the OPE network during the event. Yeah, come talk to myself or David about what to do after you've created a network, created this work group on the OPE network. I know Red Date is going to have some developers, at least one or two developers around at some point over the during the course of the weekend in Discord. So check us out there, or hop into Discord, and you'll be able to ask questions if anything comes up. But it is very much an Ethereum network, so it should work as you would expect. Thanks a lot to Tim Bailey for dialing in from Hong Kong and for being patient through our first remote Zoom dial-in for the hackathon. Yeah, it's pretty exciting stuff. Thanks, Tim. Yeah, Lane from Connex is going to be up next, but we have 10 minutes. Lane, if you want to come up here, we can get you set up. I don't think Lane heard me. What was that? What was that? So next up, we have Lane Haber, co-founder of Connects, to talk about NXTP. NXTP.
This better? Oh, yeah. All right, hi guys, I'm Lane. I'm from Connects. I'm one of the co-founders, and I'm here to talk a little bit about interoperability and the new protocol we just launched on mainnet that helps bridge EVM-compatible chains. So first, this statement shouldn't come as a surprise to anybody. Ethereum L2s need interoperability. This is going to get worse as different chains launch, different rollups launch. So I think Boba just launched, but you also have Arbitrum and Optimism and BSC and Matic and, Polygon, all these different chains where you can actually see the EVM is becoming more of a standard for, or an API layer that different blockchains can use. But if they aren't able to interop with each other, then we're not going to get the digital money future that we all want. So there's a bunch of different ways you can go about creating interoperability between these environments. In general, there's 3 main strategies. Native cross-chain validation. So some examples of this are the near Rainbow bridge and any other bridges that actually do block header verification. That is super cool, super awesome. IBC has it as well, and it's really relies on the consensus layer. The problem is it can be really expensive and really difficult to build. You have, on the other end of the spectrum, the POS or proof of stake or multi-party computation MPC bridges. Some examples of those are AnySwap, Thorchain, the Matic POS bridge, and these bridges work by essentially you deposit some funds into a contract, a set of validators validates that that has happened, and they'll mint you some funds on the corresponding receiving chain. These bridges have really excellent UX, and they're awesome, but the problem is they have added an additional trust layer or trust assumption where now you have to trust the people who are validating the deposits that have happened into that bridge. So whether it's the Matic POS bridge validator set or the Thorchain validators, all of these people are now essentially in control of the funds that you've deposited within the bridge. Then you have things like atomic swaps or one-to-one swaps, and this is where our protocol falls in, where things like hop fall in. The really nice part about this is that you don't add any additional trust assumptions, so you just have a liquidity provider who's willing to front the funds on some destination chain in exchange for taking the funds on the origin chain. And it works pretty smoothly, but it can be a bit more difficult to build, and the UX can be less desirable than the MPC bridges. So there is a fundamental trade-off when you're talking about interoperability, and that trade-off is you can't have interoperability without either introducing a trusted third party, so these MPC bridges or things of that nature, or having an implicit synchrony assumption, which means that any transfer that you're doing across chains would have to complete in a certain timeout, and you assume that it's going to happen within that time, or it's not going to happen at all. So we fall into the latter category, as does Hop and Matic, or any Thorchain, AnySwap, any of those bridges introduce a trusted third party. And this is kind of a good mental model to ground yourself in and use your intuit about when you're thinking about the trade-offs of different bridges within your system. So we chose to go with one-to-one swaps and have an implicit synchrony assumption. All of our transfers have timeouts, and I'm just going to explain a bit about how our protocol works. It's called NXTP for Non-Custodial Cross-Chain Transfer Protocol. It's a bit of a mouthful, but we couldn't think of anything catchier. So you have 2 participants in this system, a user and a router. And the cross-chain transfer starts by the user broadcasting and starting an auction. And this auction just says, hey, I want to transfer this asset to this chain, and I'm willing to accept like this amount of slippage. So the slippage can include fees or can include pricing variations that'll come in a bit later. And then the routers listen to this message and they respond with their own bids. So multiple routers will respond to the user then selects the winning bid, usually based on which is the cheapest. If there's many routers that come in the same price range, then it'll just randomly select from the available ones. Once the router and the user have been paired up, the user will submit a transaction to chain, and this transaction locks up the user's liquidity on the origin chain, and then an event is emitted that the router listens to and then knows that the user has locked up their liquidity and it's time for the router to lock up its liquidity on the destination chain. The payloads between these two calls are exactly the same, so it makes it really easy to reason about and implement, quite frankly. And then an event is emitted that the user is listening to, and the user says, great. The user then signs the payload for the transaction, broadcasts that signature, and is able to claim the funds on the destination chain. Once the signature is revealed, the router can, through the event, the router can catch this event and execute the same transaction on the origin chain and claim the funds that the user locked up. Super easy, super fun to reason about, simple. Oh, okay, sorry. So one of the things you can do with this system that's really cool is you can execute gasless cross-chain calls. So a couple of use cases that come to mind are, I have all my funds on Polygon because there were some really sweet yield farms, and I need to mint an NFT on mainnet. But I don't want to actually move all my funds to mainnet because that's expensive. So I can use NXTP to execute that call without moving any of my funds back to mainnet. Another example is there's this hot new chain opening up. They've got a bunch of liquidity mining opportunities, and I have never been on this chain before, and I need some of the native asset. So you could use NXTP to get your funds over there and exchange, say you're transferring USDC or something, and exchange some of that USDC for the base asset so that you're able to interop on the chain, or farm on the chain without having to get any extra funds for gas. So how that works is you have a user who decides that they want to mint an NFT on mainnet. So, and they have all their funds on Polygon. They prepare with encrypted call data and a fee to incentivize someone else to send the transaction on the destination chain, and for the liquidity provider to actually provide the liquidity needed to execute this call in the first place. So the transaction goes through the router, and then the router will call fulfill, which executes mint using the encoded call data. The user reveals this call data when they call fulfill, and that is passed on through and executed on mainnet without the user ever having to move their funds. And instead, they just pay a relayer fee and a fee to the router for providing this service. So now I want to talk a little bit about some of the improvements that are coming to the protocol in the near future. So one thing that we're most excited about is what we call virtual AMMs. And there is this problem in bridges of this nature where the router liquidity can get imbalanced. To be a router in this system, you usually need funds on both the origin chain and the destination chain. But if there's a lot of demand for transactions only going to one chain, your exit liquidity on that chain is going to be very quickly depleted, and you're going to have a lot of funds on some chain, and soon enough, you're not going to be able to serve the transactions, and you're going to miss out on all the fees that you could have gotten. So we need a way to create an incentive for people to balance out the transaction flow so that the router's liquidity stays balanced on each chain. And a perfect model that comes to mind are AMMs. So we can create an AMM that will price the liquidity available on one chain against the liquidity available on another. And if that liquidity starts to get imbalanced, users will actually be able to make a profit by sending transactions in a specific direction. So if you have an instance where you're seeing a lot of transaction volume go to a specific chain, like Optimism, then the price works out so that you're able to create an arbitrage opportunity between optimism and, say, Arbitrum, where people are incentivized to capitalize on that opportunity by transferring in the other direction, and then the router's liquidity ends up balancing out. So how does that work in the system? Well, it actually fits in really well in the auction process. So if a user wants to go from Arbitrum to Optimism, they start an auction, all of the routers bid, and the routers bid will contain information about the price that the user is getting based on the relative liquidity amounts on each side of the trade. So here you can see that the user gets all of these options, and they select the router with the best price, which is router 3, and then they are able to transfer across chains, and the router benefits because they are able to have liquidity balanced across all of their trades and not miss out on any opportunities. So yeah, then I just wanted to mention we have a Provide and Connect bounty, but I think Kyle is best to talk about that.
Sure, yeah. So we've been working with Connects for, how long has it been, Lane? Some years. Yeah, Connects rocks. Lane, great presentation. It's been cool to see Connects mature with the ecosystem. I mean, they're really driving, I think, a lot of maturity in the L2 space. Lane, you're going to be on that panel tomorrow. I forget what time it is. There's an L2 panel tomorrow evening. Do you know what time it is? Like 4:15 tomorrow. Lane will be there. I'll be there. Come check that out. We think the opportunity for the hackathon. So provided we're going to put a $1,000 bounty on Connext and Base Ledger. Essentially, we want to create a router that settles on mainnet. If someone develops, for example, something that listens to Base Ledger transactions and essentially creates rollup proofs as a result of those transactions, and then pushes them into a router, that would be a really cool hackathon project. Does that make sense? Yeah. Lane and myself, again, David, Myra, those would be some of the folks you would want to talk to about that. The bounty will be posted on the hackathon bounties list pretty soon. And yeah, thanks, Lane. Good stuff. So we're gonna have Brandon Iglesias up from Storage Labs next at 2:15. There's a pretty good concept that has been put together based on some conversations we'd had around using storage for rapidly syncing the blockchain. That's a pretty needed thing if you want to very quickly spin up new nodes, particularly for the enterprise. So it'll be a good one. About 15 minutes.
Hello. How's everyone feeling today? I know it's Friday, but it's an exciting day because we're here at EthAtlanta. Woo. Yeah, so first off, I want to thank everyone for coming out, and I want to thank Provide for putting this on. I'm Brandon Iglesias. I'm the head of product at Storage Labs.
And I'm Dominic Marino. I'm a solution architect at Storage.
And today we are going to be talking about building a public good for specifically around enterprise Ethereum, but really anyone can kind of use our services. So you might learn how you could leverage it with your own applications or in the hackathon. We need the remote. Aha. Okay, so hit the next slide for me. So this is just going to be a quick agenda of what we're going to be talking about today. We're going to just do a quick overview of the product that we build, which is decentralized storage. We're going to talk about some of the use cases and how you might be able to leverage decentralized storage for your applications. We're going to be talking about the performance and scalability aspects of decentralized storage and why they're so advantageous. We're going to give an example, specifically chain data snapshots. Downloading the full Ethereum blockchain in 24 minutes or faster, which is, I've been running Ethereum nodes for years, and syncing Ethereum nodes can take a lot longer than 24 minutes. And then after that, we're gonna go into questions and answers, and this is definitely gonna be quite an interactive session. So please, we're gonna pause at some of these slides, and if you have questions about the architecture, or if you have questions about how the system works, or just random questions, please feel free to ask. We're both motorcycle gearheads, so if you have motorcycle questions, you can also ask those.
All right, so let's kick off how it works. Brandon is going to go through this section of the deck, and then I'll pick up the next slide.
That sounds good. Okay, so decentralized storage, how does it work? So the way that we've architected decentralized storage is we have three major peer classes in the network. We have uplinks, which are people who have huge amounts of data, people like the Ethereum blockchain. We have satellites, which tend to keep track of the metadata on the network. And then we have storage node operators who basically have a ton of underutilized resources that they want to monetize. So if you think about these three different peer classes in the network, essentially what they do is they interact with each other to make it so that you can store large amounts of data without us owning a single hard drive. So Storage Labs, the company, doesn't own any hard drives, but there's about 15,000 nodes on the network who all dedicate different levels of resources. Some people dedicate 2 terabytes, some people dedicate 20 terabytes, and so on and so forth. And all of these individuals on the network are compensated depending on resource utilization and depending on how much data is uploaded and downloaded from the customers. And I think this is actually probably a good place to pause.
I'm going to loop back through it just very briefly. Again, we've got the uplink. That's how you interact with our network. You, the consumer, will use that uplink via a bunch of different modalities to send that data into our decentralized cloud. Now, that satellite is the responsible party, right? It remembers what's going on. And those node operators are, we're in the teens of thousands now of independent node operators that are statistically uncorrelated, so that when we take your data and erasure code it, which you've encrypted it, by the way, and send it out into the world, it's truly decentralized, and it's over a device, a diverse array of devices around the globe. So does anyone have any questions on that structure of the network on the peer classes? Anyone lose any data? Anyone ever retrieve data far too slowly? No? Okay. So we'll jump into the next slide here, and we'll talk a little bit more about how it works. So as an architect at Storage, I always get to say, Brandon has a lot of fun in product, but I get to have like all the fun. I get to play with all the toys. I get to work with all the prospects and really find that good fit. So when you're putting data onto our network, you have the option of running that uplink, that utility. Think of it as an uploader. You are then the custodian of your encryption keys. I'll repeat it. You are the custodian of your encryption keys, not us. That means if you lose your encryption keys, we can't restore your data. That's a really, really good thing. So when you do that, when you upload a file to our network, let's imagine that the file is 64 megs. It's a nice, easy number to use. It happens to be our block size. Well, when you upload that file, you're going to encrypt it with your encryption keys, and then we're going to take that file and split it into 80 pieces. Now, we send those 80 pieces out to statistically uncorrelated nodes around the globe. Thus, you have a bunch of parity on the network. It's very similar to how RAID works in the storage arrays we used to use, or we use in centralized solutions today. So when you go to pull that file back, well, you're only going to need 29 of those 80 pieces to reconstitute your file. And what's really cool about that is you can lose a whole lot of nodes around the globe and not have any impact in performance or the resiliency of your file. Now, what differentiates us from a lot of other offerings in the decentralized storage space is the fact that we automate that repair. So you go, well, what happens when 2 or 3 or 5 nodes drop off the network? Our satellites are constantly monitoring, auditing the health of the network and the health of your file. Now, again, we don't know what your file is, but we know that 2 or 3 pieces are missing. So what we'll do is we'll go out, grab that encrypted file, and repair it. And you never know or care. So there's an entire layer of your application, your decentralized application, that you are now no longer responsible for architecting and maintaining. We take care of everything. You just pay your storage bill, and you get to use decentralized, reliable, performant, and high-value storage without any of the complication. Does anyone have any questions on the erasure coding aspect, the encryption, any network fundamentals? No? Nope. So we charge $4 per terabyte per month for storage. So if you store 1 terabyte and you store that terabyte for a year, you're paying every month. And then we pay we charge $7 per terabyte of egress. And then we just do a flat scale. So if anyone has ever procured IP transit globally, you know that North America and the European Union is fairly affordable. But you go into South America or APAC, right? Or Seoul, specifically in APAC. And all of a sudden your wallet is now, well, lighter than it used to be. We charge $4 and $7 globally. And we have ingress points to the network if you do want to use a hosted gateway versus natively integrating into the product. And we have those points of presence currently in North America, specifically Toronto. We have a point of presence in the European Union in Frankfurt, and a point of presence in Asia Pacific in Singapore. With that,
I do want to add something to that. So we charge $4 per month for storage, but that's multi-region storage because your data is distributed across the network of nodes that we have around the world. So it's like if you were going to do multi-region data storage on AWS, you're typically paying 2 or 3 times the normal AWS fee just because you're paying twice the amount if you're doing multi-region in 2 places. So we're multi-region and still $4. I mean, it's pretty cheap.
and we have extra slides in performance and resiliency, so keep them coming.
We had one question over here. So the question was,
you mentioned like having like 80 and then like only using 29 and still having data. Like,
so the concept of erasure coding, which has been used in RAID forever, we put extra parity out into the network. And without getting into too much detail, know that we put 80 pieces out, but you only need 29. So parity, what's the best way to explain parity?
I would say like, yeah, so like RAID sometimes uses replication versus parity. And like when you replicate drives, that basically means that you have 5 hard drives, and if you have 5x parity or 5x replication, each of those hard drives will store the exact same thing. We don't do that because replication is really expensive, like literally mirrors of the data. So the erasure encoding that we use allows us to create unique pieces of a file, and you only need a subset of the superset of those pieces to reconstruct the file, but it's any of the pieces in the subset. So when you have a file that is about 10 megabytes, it gets split into 80 pieces, okay? But you only need 29 of those 80 pieces, and it can be any 29, right? So let's say all the people in this audience are storing 1 piece for a file. You know, if some of you walk out of the room, it's okay. It doesn't matter which of you walk out of the room, as long as we have the minimum number of pieces required to reconstruct the file. And when we were talking about the architecture previously, the satellite, which is that layer that sits kind of on top of the nodes and the uplinks who are uploading the data and storing the data, the satellite is responsible for auditing the nodes on the network and making sure that they're keeping the pieces that they should be keeping. So the satellite kind of acts as a puppet master and keeps track of the metadata to make sure that as a client, right, if I'm using S3, I want to store my data, walk away for a year, and then download it when I need it. You have the same advantage on our network because the satellite is just maintaining the availability and durability of all the files on the network.
Simply put, you don't have to worry about it. Yes? Absolutely. So we do that automatically. It's an audit process that runs on a continual loop. So we're always doing that. I forget the exact number right now.
It's 56 pieces. So if you upload like a 10 megabyte file, there'll be 80 pieces uploaded to the network. When it gets to 56, the satellite will download some of those pieces. When it downloads those pieces, it can't see it because they're client-side encrypted. So it's downloading blobs of data. But then we'll perform a retelling and erasure repair. We'll upload new pieces, and that file will go from 80 to 56, get repaired, go back up to 80. So every file that gets uploaded to the network actually has a natural churn. And we have graphs over the last 3 years of files that have been uploaded, gone up with 80 pieces, gone down to 56, and so on and so forth. It's just a natural decay and replenishment.
The key, though, is you never worry about it because you don't have to manage it.
Exactly.
It's just done. And we pay within our economic model. We've built in the cost of repair and thus have built an economy for which the node operators are consistent. They are reliable, which reduces the repair need because they're incentivized to stay on the network. So it's a careful balance to build that economy, but we've done quite a good job at it. Ready to hop?
Yeah.
All right.
Okay. So, yeah, I guess next we could talk a little bit about the ease of use. So as an uplink or someone who has tons of data, I used to be an engineer and I used to integrate with APIs and different libraries. You can do the same thing with storage, DCS. So you can integrate with one of our native libraries, or you can use an S3 gateway. And then we have a number of different tools that you can use, such as rclone or Duplicati, that have native integrations as well. Do you want to add anything to this, Tom?
Oh boy. Yes. So we're going to get into the performance and the resiliency. So there are different ways to interact with the network that have different benefits, right? There's always a better way to do something, and it's really specific to what you're trying to accomplish. So we found that some processes even benefit from two ways of interacting with the network. So for instance, when you upload to the network, and let's call out that extra parity, the 29 of 80 pieces, well, that means when you're uploading natively, you have to upload 2.68 times more data. You upload a gig, you're actually uploading 2.68 gigs. Now, that's generally not a problem, but let's imagine you don't want to do that. Well, we host a gateway, which has us do the encryption and erasure coding. We don't record your encryption keys, but we do the encryption for you. It is completely an option, and that allows you to upload at a 1x, right? 1 gig is 1 gig. But when you're downloading, it's always best to go to the nodes directly. So running that uplink and pulling your pieces back in parallel is always faster. And we've demonstrated speeds recently upwards of 6 gigabits of throughput from a high value decentralized object store, which if anyone's a network engineer or they have experience in that area, I mean, we're talking hundreds of megabyte throughput, which exceeds even the write rate of a lot of disks from a decentralized platform. So there's an option for everyone. And if today you're using something that is S3 compatible, you can plug that in. It's 3 lines of code, right? It's your endpoint, your access key, and your secret key. And if you wish to dive in a little deeper with the native integration, which for the decentralist in the crowd is most certainly the way to do it. We have libraries for many languages. So we're here to support you, and if you need help, let us know. Jump to typical use cases. So, boy, I've got some favorites here. we've been doing a lot of projects with customers recently in the video streaming and storage space. So a concept that's very important to understand is we talked about 64 meg block sizes on the network. That means if you're going to put something on our network that's 64 or 10 megs, it's going to be one thing. It's going to be one segment. But if the file is bigger, it's going to become multiple segments. And the advantage of multiple segments is you get 80 pieces per segment. So all of a sudden, if you're uploading, let's say, a gig file or a terabyte file, you're getting to hundreds or tens of thousands of pieces on the network, which means when you go back to stream it, you have the ability to survive viral content. So the more pieces that are out there means the more nodes that are supporting your particular file. And we actually have a great streaming use case that we can demo to anyone that wants to see it after this. But you can stream 4K 60 frame video from the decentralized cloud without any buffering. Like, we do that today. We host a lot of our own training videos, a lot of our information videos. It's not a CDN, but it acts like one to a point. So if you're hosting media content on your site and you want ultra low cost egress, that is the ability to send that data out to the world at low cost, this is a great intermediary solution. And if you want to combine it with a CDN, we work great with Fastly to buffer at the edge, meaning if you have the next viral, forgive me, cat video, you can utilize a combination of us and a CDN partner like Fastly to serve it to an unlimited number of people. Really, cloud native web application, storage apps. Storage is huge for us. It's kind of in the t-shirt. So what I mean by that is MSPs love the service because they're always looking for performant, low-cost storage that is resilient. So we will sign an SLA with you that meets or exceeds what, for instance, a hyperscaler will do. We have 11 nines of durability. We've just actually we've never lost a file, but we guarantee 11 nines of durability. In addition to, we guarantee, is it 99 point? Yeah, it's four nines of availability of your file for the first try. Yeah, so it's a great SLA and it meets most corporate requirements. When it comes to large distribution of files, that really goes along with video, right? It's the same thing. If you're gonna download a large file, it's very equivalent to streaming video. And then, did you want to add anything to it?
Yeah, so the one that we're going to talk about here in a second is the blockchain fast sync use case, which I think a lot of you might find interesting. So should we dive into it?
So I am curious, who in the crowd runs a Geth node or runs an Ethereum node of any type? Okay, we got one, we got two. All right, so we'll talk directly to you in this next part. So, we'll do performance first? Okay, got it. Did you want to dive into performance?
No, you go.
Okay. All right, so everything we do is multi-region. There's not a single copy of anything we're doing out there. And when we talk about performance and scale, you can see an example. This map is actually from the community. We like it so much, we decided to use it. And it shows the density of storage nodes. European countries really have fair bandwidth policies, so we find we get a lot of adoption there because they get unlimited upload, which is very important for our network, because if you're a node operator, how do you make money? Well, you store files and you give them back, right? We pay you to store, we pay you to upload. So Europe's very popular, as in the United States, we have some more restrictive ISP limitations. That is, your typical Xfinity tends to cut you off at a terabyte or two. Now, when we talk about the performance and scale, what's really interesting about our network, and I've championed this with a contact at the University of Edinburgh who is working on a supercomputer project where they're sharing these enormous data sets. So what we've done is, remember we've got the segment, and remember we need the 29 pieces of the segment. Well, when you go to download a segment, it's going to download that segment in parallel. So all those pieces that you need come down at the same time. But what gets really cool is if you have a big file, it might be made up, let's just imagine it's 10 segments, right? So all of a sudden you've got 10 segments, and traditionally those would download serially. So you'd have a parallel effort to the next parallel effort to the next parallel effort. And what's really cool is recently working with product, working with customer feedback, we've enacted segment parallelism. And it sounds kind of complicated, but the concept is this. Please give me all of my stuff at the same time, please, right? Now, there are limits. You can easily take down your internet connection or overload your router if you type crazy numbers into it. But that's how we've gone from demonstrating speeds of, let's say, 50, 80, 100 megabyte throughput, and we've gotten to the multi-hundred. So we find that using a consumer laptop, think MacBook Pro, it's pretty easy to get above about 1500 megabit. I'm changing standards, but megabit is the best way to explain it when comparing it to how your ISP, for instance, advertises the speed. So we can go about 50% faster than a gig internet connection using consumer grade hardware, nothing fancy, no really cool servers. And that enables this blockchain fast sync case that we're going to be demoing today.
I'll go to the next one.
Fantastic. You want to talk Volunteer?
Yeah. So when you're downloading a file from the network, a lot of you might question like, well, I only need 29 pieces. How am I actually downloading this file, right? Like Dominic talked about parallelism for pieces that are getting downloaded and parallelism for each of the segments that are getting downloaded. And part of the reason that we can do it so quickly is because we have this thing called long tail elimination. And essentially what that is like, hey, I only need 29 pieces, but if you're only downloading 29 pieces, then you're only as fast as the slowest node. So what we do is we actually download from more nodes because we have such a big pool, right? 80 nodes are storing a piece of your file. So we download from about 35 or 36, or you download from about 35 or 36. And when you get the 29 pieces that you need, you kill the other connections, you take those pieces, reconstruct them and decrypt them on the fly so that
you could call it a race to the end, right? You got everybody lined up, and the first 29 runners that make it in the gate won. And the rest of them, you don't need.
Yeah. So that's part of the reason that we're able to download data so quickly. I'll go next. And to the example. So if you want to try this out yourself, you actually can. We have two methods for you to try it out. You can download it via one of our edge services that Dominic was talking about, or you can download it with the uplink natively, which will get you way higher throughput and speed. But if you go to fastsync.storage.dev, you can actually go download the entire ETH chain state right now.
So it's from the 28th, I believe. It's the ETH, it's ETH chain state. Yeah. And we highly encourage you not to ever trust anyone else's chain state. So this is a demo. That being said, if you're running multiple nodes yourself and you want to replicate, this is most certainly the fastest way to do it. So we've got this thesis we put together here. You can see we're actually using a Vultr VPS just for full transparency. And there's 3 lines. And what we want to point out here is the traditional sync model. We all know that synchronizing an Ethereum node can take, well, I don't count it in hours. I tend to count it in days sometimes, particularly if it's an archive node. So what gets interesting here is you have guest snap, right, which is fast, and then you have us. And the difference here is, let's imagine you're running a full node. Well, how do you best replicate it when you trust the chain state? Well, you stop the node and you copy the database. You put it on your next node, you turn it on. Now, again, you only do that when you fully trust the source of the chain state. But if it's you or your organization, then of course you trust the chain state of the node that you're running. Now, what we've implemented here is massive parallelism. So on this Vultr, so Carl did it in, I think, 2 hours in the example that he was running here. But utilizing a virtual machine with 16 vCPU, and I believe it was 96 gigs of RAM, but I didn't get near the limit of that memory, I was able to bring a node up in 24 minutes. So depending on the compute power available, you can sync in, we've demonstrated 24 minutes. In full transparency, At a chain state, I think it was 368 gigs. It's 378 gigs, 368 gigs, right in that area. If you have flexibility in your compute and you can scale up and down the CPUs you have available, you could probably get that to 15 minutes. Now, how does an organization like Binance or a large player in this space actually replicate their nodes today? They've not told this to me directly, but you do it in a building on a really fast network, and then you take a box that says overnight, and the node flies on an airplane. So before this, your options were quite limited in fast replication and literally involved aircraft.
Yeah, I mean, syncing an ETH node from the beginning takes weeks, especially if you're doing it on consumer grade hardware. So being able to do it in 25, 30 minutes is incredible.
And that's what we feel. We've been enabled by Ethereum, right? Our economy for our product. It's how we pay node operators globally. And now this is kind of our thing we feel we can help the community with. So with the lack of proliferation in node count, right? As nodes get more centralized as Ethereum grows, this is a great way to ease the burden of running your own node. Anyone have any questions on that?
Go ahead.
So you're using Binance as an example. So you're saying that when they want to stand up another data center somewhere else, and they want to include every bit of history of every single transaction pair for whatever length of time that they've been running, this is, for them, would be the most effective option to put it in a airplane, have UPS take a hard drives.
Well, so until recently, the largest transfer of data that occurred on a daily basis was a company we call Netflix. And it was through the US Postal Service. And it was Blu-ray movies, right? 45 gigs per movie. So the most data moving in the world was literally Netflix. So it's hard to beat replication in a local environment. So you're in a local environment, you're gonna have 100 gig network. You're gonna have the best hardware. You're gonna have a bunch of NVMe disks. You're gonna have tons of compute, tons of memory. This is actually a viable alternative. Now, what is ETH archive nodes right now? 8 terabytes? It's something around that. And that's a lot. I mean, that takes, even at high speeds, that takes weeks to move. But when we're talking about hundreds of gigs, all of a sudden you get to take the airplane out of the equation. And that is most certainly how today, per my reading and conversations in the industry, archive nodes in particular are being replicated. Now, we're really focused on full nodes in this talk, but if anybody here wants to try to replicate a archive Ethereum node, I mean, I'll say I have the ability to provide some development credit and work with you. I don't have the resource myself to run one, but if somebody has a full archive node, boy, would I love an export of your chain state, and I would love to throw it up on the network and do some testing. So please see me if you have an archive node and you would like to experiment with it.
What's your payment options?
What was the question?
Payment options.
Oh, so we have a couple of payment options, but we only have 1 minute, so maybe we can cover that. We'll go over to your table.
Storage token and USD.
Yeah. So we're getting clapped off, but if you want to try this out, you can just go to that URL. We will also give you basically as much free credit as you want. If you're a developer or you're participating in the hackathon, we're more than happy to give you a bunch of free developer credits on our product so that you can use it for the next few months or however long you'd like. And if you want to learn more, you can go to storage.io or email me at brandon@storage.io or dom@storage.io.
I'm going to need that email now.
Yep.
All right.
Oh,
Thank you, Brandon.
Dominic.
Yeah, but it's fine. Thank you, everyone.
Great presentation. Great presentation. Next up, we have Gage to talk about entropy beacons and base ledger. Hey, bring it in. Bring it in. Hey, we're just doing a selfie. It's cool. All right. Guys, we're going to get kicked off with this next one. I like this one a lot. It's about base ledger. Sorry. So we want to basically come up with a way to inject randomness into base ledger. This is fun. Yee.
Hello, Atlanta.
Yee.
You guys are real excited out there.
Yee. Jack, do I have enough energy now? Yeah. Nashley says, yeah. Huh? What? Too loud. David says it was too loud. All right. Yeah. All right, guys, we're going to get started.
All right, everyone. My name's Gage, and I'm here to present about a base ledger entropy beacon. Special credit to Kyle for the initial code work on this. So what are we covering today? We want to use base ledger to query the existing Chainlink VRF deployment that's on Ethereum. Why is this needed? What are the uses and pitfalls? Why Chainlink? And how does that base ledger to Ethereum communication look like? So we want to introduce a little chaos into base ledger. We need entropy for the ZKPs. Base ledger, as the blockchain for baselining, needs to support generating zero-knowledge proofs, which are critical to the baselining process. These ZKPs need random seeds, also known as entropy. Specifically, these are generated as part of a multi-party compute setup between all the parties that are engaging baselining their data together. These proofs need to be matched, they need to be aligned, everybody needs to be using the same source of entropy, or the verification fails, and you wind up with a situation where you're finger pointing and you lose the value of baselining if the proofs cannot be verified. So we want some randomness, but we don't want it so random that nobody's on the same page. So how do I know that your entropy is my entropy? Well, let's just use the lava lamp on my desk. That's nice and random. I'll provide the entropy. Well, that's fine until I mess up, or you have somebody on the network that's malicious and they start using their own entropy. Now our proofs don't match and our baseline's unbased. So how do we determine who's right? I say I'm right, you say you're right. We're back to the traditional problem of everybody in disparate systems finger pointing. But if we had a third party providing the entropy as the standard value, we could check against that. Everybody could be dishonest. We just go back and check against the known honest source, and we trust that. But what could be so trustworthy? Chainlink. Chainlink has a verifiable randomness function that they provide, and this can be our golden source of entropy. Chainlink VRF comes from a set of neutral, decentralized node operators, and what's important about their randomness is it also includes a cryptographic proof, verifying that the randomness has not been tampered with. So, how can we be so sure that this random value from Chainlink is not also gamed? What makes it more credible than the users in the multi-party compute? Why can we treat this as the golden seed? Here's a nice diagram of the VRF process. You have your smart contract requesting randomness, goes off into the Chainlink network, they do their work, send it back to the VRF coordinator contract, and then the smart contract receives the randomness. That step 3 there is the important one. That's the verifier. That's where the magic happens. This contract contains an implementation of Goldberg's verifiable random function. So essentially what's going on here, we have a known seed value. We have a known elliptic curve that we're generating randomness off of. And all the node operators that are generating the randomness, we know their public key. What we don't know is the randomness. We have all these other factors, though, that we can essentially work it back on the curve and confirm, okay, this randomness followed the procedure, everything traces back on the elliptic curve, everything is as it should be. If someone tampers with the randomness, now suddenly this verification function would fail. You're not going to be able to solve it back correctly in that case. So we would reject the random data. In this way, we can be 100% sure, cryptographically sure, that the randomness generated wasn't gamed. It was generated as supposed to be. You can find the full cryptographic details on that if that's interesting to you, all the equations and everything for that algorithm. The content team at Chainlink put out a nice blog piece for the announcement of VRF. So how do we use Chainlink VRF? Well, currently it's integrated on Ethereum, Polygon, and Binance Smart Chain. Wait a second, there's no base ledger. Okay, we're done here, thank you. Not so fast. Conveniently, base ledger is built upon Tendermint with cross-compatibility in mind. So by design, base ledger can query Ethereum using the Tendermint blockchain interface, or Tendermint application blockchain interface, ABCI. So this is the core idea behind the presentation. We may not have a native Chainlink VRF implementation yet, but we do have the ability to call it on Ethereum, retrieve that data, and bring it back into base ledger. So here's a diagram taken from the base ledger white paper showing where it exists in the stack. And you can see it's just kind of layered nicely right there above Ethereum. So we can call back and forth between there. And that's where this idea exists. So we have this concept now of a native VRF versus this queried VRF. So we're doing something that's not really by the books. It's not the intended design of VRF. So we need to start asking ourselves, well, is there a way that we're breaking something? Is there some vulnerability we're introducing here by not using a native VRF integration? And actually there is. There is one core weakness that should be kept in mind here. Can't be used anywhere where being privy to the random data gives you an advantage. So since we're reading from Ethereum, it's possible you could go and look at Ethereum first before it's retrieved back into base ledger, and now you have advanced knowledge of the randomness. So that could lead to you gaming the system, getting that ultra rare NFT mint, snagging it right before somebody else gets it because you saw, oh, this randomness is gonna generate this handsome reward. So we just need to be careful here of that consideration. So it's broken. No, not quite. It just has that very important consideration. This query from another chain style is fine for multi-party systems where the advanced knowledge doesn't give you an advantage. In this case, we just need some known good source of entropy that we can cross-check against everybody generating ZKPs. We just want to keep everybody synchronized with the same entropy so the proofs all verify at the end. So if party A sees it before party B, that's fine. They're both using the same value anyway. If something changes, it no longer matches, the proof verification fails, and we start over until everybody decides, hey, we want to be honest. There's really no advantage to being dishonest in this system. It fails at the end in the verification. So just keep in mind that important note there. If having advanced knowledge lets you game the system, this is not a kind of architecture you'd want to use. So how do we do this? Well, we need a VRF consumer contract that we can query, and that exists on Ethereum. We need a way to initiate a VRF call from base ledger, and we need a way to get that data back into base ledger. So the first part, deploying a VRF contract, that's easy, that's standard. There's nothing different here from when you would be deploying it on Ethereum for your use on Ethereum. There's a standard template for this you can find in the Chainlink docs. Follows the normal Chainlink request and receive architecture if you've ever made an API request from Chainlink. Same style there with the fulfillment callbacks. So really you just inherit the Chainlink VRF contract, And then you just need to create your own two functions here, requesting the randomness, and then where the nodes are going to call back to fulfill with the random data. This is what that contract looks like. You can see we just have the single import at the top there, the VRF consumer base. Then we define our contract as inheriting from that. And we need to specify this key hash here, which is the seed. In this example, we have it hard-coded. Obviously, in production, you would generate that in a better manner. Then the address of the coordinator, that's that contract that's doing the verification, and that's going to depend upon what chain you're on. Address is different on Polygon versus Ethereum, et cetera. And then at the end, we just submit our request for randomness, give it our hashed seed, provide a fee and link to cover the node operator's gas costs and their work. And then the node operator, or rather the VRF coordinator contract, is going to call back this fulfill randomness function, and that's where you get your random number. That's it, just one contract. Most of it's handled in the inheritance. You really just need to define the request and the receive. And all that verification, if you notice, there was no verification in that contract. That's all handled by the coordinator. The coordinator would automatically reject the randomness if the verification fails. You can find out more information on this in the Chainlink VRF docs link listed below. So now for the base ledger work. Kyle here was nice enough to get us started with a commit, and here he comes to talk a little bit more about that.
Good stuff, Gage. Yeah, so we got this kicked off. The ABCI application blockchain interface in the base ledger Tendermint project is receiving callbacks, and we were thinking about using a block header to stuff the entropy in like once every 100 blocks or something. There's a fetch entropy method that needs to actually call the smart contract on Ethereum to do the work. And once it returns that, it will, we want to, I think, stuff that into a block header. So that's sort of the idea. The code base is on the base ledger repo. So github.com/baseledger/baseledger core. And again, this is a $1,000 bounty from Provide for this item. Yeah, I come see me. We can talk about how to get started with the code base that exists today, and you'll be well on your way to $1,000 bounty. Yeah, so this is listed on the bounties. I believe have been updated on docs.provide.services/hackathon/developers/bounties. You can find links to these slides and links to all the relevant resources there as well. And yeah, just come holler at me, and we can hack on that. Gage, you rock, man. This was a really fun project. I think someone will really have a good time with it. Thanks a lot. So I think we're just going to jump right into this next one. Simon, Edge and Node has a really cool presentation related to base ledger and subgraphs. Oh, yes. And we're back.
Hello? Ah, it works. Yeah, I think we can get started. Hello, everybody. My name is Simon Emanuel Schmid. I work as a solutions engineer for the company called EthAtlanta. We are the team behind the graph, the original team. In the meantime, other teams have joined, namely Streaming Fast and Figment. So it is kind of like already the development of the graph is kind of decentralizing at the moment. So today I want to explore the possibility to write subgraphs for base ledger, so what's possible currently. But before we dive into the base ledger subgraph, I want to quickly tell you about what is the graph by itself. So on our website, it's called APIs for a Vibrant Decentralized Future. Kind of, this is the buzzword, the marketing speech. Technically, it is an indexing protocol for querying networks like Ethereum, IPFS, and actually also a lot of others. So currently we are, like the graph supports different EVM-compatible chains like Polygon, Arbitrum, Optimism, Binance, and so on and so forth, Phantom, and more like even non-EVM compatible chains are in the making. Also, we are looking at other storage solutions than IPFS. Because this is a little bit the enterprise IT thing here, I heard. I want to quickly kind of show you in this setup, like how is an application commonly structured. So on the top, we have the presentation layer, that's usually the UI. Then we have kind of an indexing layer that prepares the data. Then we have a business logic layer, where you kind of have the business logic or how your application should work and what are the rules. And then you have a data layer where all the data is stored. And on the bottom, you have kind of a network layer where the applications talk to each other, or kind of, if you have it on your computer or on a server, usually there is some chat between computers. So in a traditional application architecture, we see that the top layers, they are centralized or even locked. So let's say when you are browsing Facebook, then Facebook owns the UI, your data, the business logic, and everything else. The only thing that Facebook does not really own is like the network layer, because this is the internet, and it's on top of open protocols like HTTP and IP TCP, you probably know. But the problem is like the data inside of Facebook doesn't belong to you. And if they go out of business, then maybe all the relationships that you created in Facebook are just gone also. Then the Ethereum and Web3 space came actually to challenge the status quo, and came with this initialized, like decentralized application architecture. Like also this word DApp comes from decentralized application. So the idea there is like that even the presentation layer, but also the business logic layer, which in Ethereum speak are just smart contracts, and also the data layer are decentralized again. So kind of the data ownership shifts completely away from central entities to the users or to the networks. The problem that we saw in this special architecture is like to query data from the business logic layer and the data layer was very slow. For example, like when you want to see Uniswap, the trading histories of a certain pair, then usually you need to look through the blockchain like transaction per transaction and find the trades, and then you can kind of build your candlesticks or whatever chart you want. And that is actually where the graph jumps in. Like, this is the Web3 architecture that we are building currently. So you have a presentation layer that can be still centralized or not, but it can be, especially what's important, it can be changed. So for example, if you own NFTs, then it doesn't matter if you look at them on OpenSea or on Foundation or on Showtime or whatever future cool NFT app will come, because you own the private keys to your address, and all the data is kind of publicly available. And we see like the graph really is at this indexing layer point. With the business logic layer, we have like Ethereum, but other chains coming like Near, Solana, and also a base ledger somehow can be at this business logic layer. And then with data layer, we have IPFS and Arweave that we are looking at, and others that we plan to integrate. And on the bottom, again, we have still the networking layer, because even we still build on top of TCP/IP and HTTPS. So a little bit a marketing slide. So currently the graph is delivering 1 billion queries per day. This is a number from the hosted service, which is currently a centralized thing run by Edge and Node. But we are planning to, we launched a decentralized network in June, and since then it's possible to have like subgraphs deployed on a decentralized network in a truly decentralized way. As I said, like key applications or key dApps building on top of the graph, like Uniswap, Enzyme, Artblocks, UMA protocol, and SushiSwap, and more. So like there's, most big dApps actually on Ethereum, they build on top of the graph. So I think it's a core infrastructure. As I said, in June, we launched this decentralized indexing network protocol. I don't go very deep into it, but roughly the idea is that you have like different players. You have curators, indexers, delegators, developers, and consumers, which all kind of are incentivized through the network together to work together in a decentralized way to have this unstoppable network of data, if you want to. I'm here for the whole weekend. And if you want to dive deeper into the network economics of the graph, I'm happy to give a quick primer, or when we have time after the presentation. So the next thing that I want to look at is like a base ledger subgraph. Because like the graph natively does not support base ledger yet, but because the base ledger wants to integrate or can integrate with Ethereum, it is possible to see what's going on there. But first, I quickly introduce you to the concept of a subgraph. So a subgraph by itself is basically a database schema definition. As you see, the database icon with this dots, it's not actually a database, it's just a definition, plus an instruction set, how you can watch the blockchain for events or calls or other things, and then take this out, transform it in a way so that you can put it back to that database in a way so that it is available for your dApps to query fast. So it's more or less kind of making, extracting the different protocols from the Ethereum blockchain and store what's important about them in a database for quick retrieval. And the subgraph by itself, this instruction set will then be sent to indexers, and then they start to execute that instruction set and index the subgraph. This is quite heavy, so some subgraphs, like if you do have a lot of events, a lot of going on, this can take several days. Although we are really working on making the indexing speed more faster. So this is something to improve, but just to say, I mean, like, it is for an indexer, it's kind of an investment which subgraph to index. But looking at now base ledger, we can talk a little bit about the concept of a bridge. So like every other chain or every other system that kind of interacts with Ethereum, at some point there is a bridge. Like even like if you have a centralized exchange like Kraken or Coinbase, at some point they will send Ethereum to the Ethereum chain, and that happens with an address. And with the graph, we can watch these bridges and see what's going on. There are like not so complicated bridges like exchanges where you just see tokens and ether flowing in and out, but there are more complex bridges for the upcoming, or for the layer 2s, where there's actually computation that you can watch on the Ethereum main chain and then make meaning out of this and kind of track what's going on that bridge. And this is actually what we try to do here. So I prepared a little bit of live coding. I hope it works and it holds, because it's more fun if we actually see it going.
Simone, let me know when.
Sorry? Ah, yeah, sure. Hello? Do you still hear me? Okay. For those who want to follow this live coding, there's this QR code that links to a GitHub repo, which is the thing that I also use here. So it is this one. So as a first step, you probably need to have the Graph CLI installed. So you see this here. I did this already. But now the next thing we can do, we can say, okay, we are interested in this contract. So this is the staking contract for Base Ledger on Robston. So we can click here and also see what's going on. Like there are transactions on this contract. We can also read the contract here. Yes. So as a next step, I can just say, I want to create a new subgraph. I initialize it. I use the host service because Robston is not supported on the decentralized network yet. Otherwise, we could use the studio. But now we use the host service. Then we can say which contract, which network. Then also here, this index events is actually going into the ABI and looking at the events and start to automatically generate code that indexes those events. And then we can also give a contract name. Let's see what happens. So, okay, so the subgraph name will be like Base Ledger subgraph. Oh, I forgot one step. First, we need to go to the graph website and create the subgraph. Because we're using the legacy explorer, the way to go there is to click here on the graph explorer, and then here is kind of a very hidden link to the legacy explorer. Then we go there, and then we are on the legacy system that still supports Robston. On the top right, if you're not logged in, there's kind of a login with GitHub. I can just click here and go to my dashboard. And then I can click here and create a new subgraph. And then I say Base Ledger subgraph. I can have an account. If you have Teams, you can add it here. And also what's nice is if you actually add your GitHub URL, so people who look at your subgraph later on, they can also check the source. That's it. So now I already have created the subgraph on in the Explorer, but now I just need to actually deploy to it. So the thing here is this is kind of my subgraph name. It's kind of my GitHub handle slash the slugified name that I wrote before. So this is what actually they're asking me to enter here. So the subgraph name is this. Yes. Okay, and then it asks me a directory to create in. I take this Base Ledger subgraph, sounds nice. Then I do Robston, contract address I gave before. The contract name also I gave before, that's how it knows. And then it goes. It starts to clone everything and go into it and install dependencies with Yarn. we don't need to wait for yarn, we can just go into there. And start to inspect the code. So what we have is this standard repository comes out of a boilerplate. So when you inspect the subgraph, the first thing that I look at is the subgraph YAML file. So what we here have kind of the rough definition. So we say like, okay, where's the database schema and where do I get data in? So here we have like, it's from Ethereum, it's on Robston, the name is staking, there is the address. And also here I have the entities which come from the schema. And then where the API is, it also has downloaded the API from Etherscan. And then already some event handlers. So we see like, okay, this contract emits deposit, ownership transferred, and withdrawal events. They are already created for us, which is cool. Yeah, we can also look at the schema. It's also automatically generated because we're indexing events. So this is actually not a GraphQL schema, it's a database schema that confuses a lot of first-time subgraph developers. But we have like entities, which are tables. So we have like a deposit entity. Like for every event, we kind of have an entity. So far, it's quite straightforward. But yeah, we see like there's everything has an ID. There is beneficiaries, and there's an amount. So like a staking contract, you put some money in, and you just withdraw money. And third thing that's created is kind of the mapping file, where we have like these files. This is actually not TypeScript, it's assembly script, so it's a little bit different. But we have these files, these functions that do what they should. I mean, it's pretty straightforward. So handle deposit, gets a deposit event, creates a deposit entity, fills the data, and just saves it. That's it. But what is cool is that we can run this already. One thing that is not auto-generated is start block. So you can easily get the start block from when you look at the address, the contract, then you see at which transaction the contract was created. Then you can follow the contract address and get the block number out. Because I mean, it doesn't make sense to start with block 0 when you know like that the contract was deployed at this block 10 million. So that's what we do. We go to the subgraph YAML and add the start block. Start block. Okay, now we save. And then actually the next step is simply yarn. So now here I think it's installed, that's cool. So we can yarn build or yarn code again. This generates some helper functions. So we have kind of this intelligent thing in the IDE where we can start to inspect the objects. And then we can do yarn build to check if the build process works. And this works, so I can just deploy. The deploy script here comes from here, so it's everything predefined. Also, what I did before that you see in the GitHub repo is at some point you need to authenticate yourself. You see it here, this is my access token. No worries, I will kind of create a new one later, but you can find it there, and then you need to authenticate yourself so that this works. But other than that, I already deployed like my minimized base ledger subgraph. Like it's more or less the boilerplate to the host service. Actually, I can just restart here. And then we see it's already indexing. We have to have the query here, and we can run the query. And interestingly, it already sees some deposits and some ownership transfers. Yeah, cool, right? I mean, like this was like, yeah, 10 minutes, and we already have kind of a first subgraph. But now I think this is too easy. I mean, we just indexed events. And that doesn't make it interesting. So when we look at contract, we can look at the contract here. We know it's kind of what's happening here. There are deposits, there are withdrawals. But what's actually interesting is I don't want to see just the deposits and withdrawals. I want to see like I can want to query for an address and see like how many deposits has this address and know how many stake is it there. So can we add to it when we see deposits and we subtract from it when there are withdrawals. So let's explore that. For this, we create a new entity called account. And that we do in the schema. And then we can also link the account to these addresses here. I have to say I cheat now a little bit because I prepared everything. So there's quite some changes here. We can walk through them. Oops. All right. Okay. So what I did is like I removed the handle ownership because it's not so interesting. I mean, like it's just like the contract is owned by someone, then it can change. We don't care. We care about the deposits with withdrawals. So we can also delete that function. And then also we created this account entity and started to link it. So we link it here. So I say the sender is not like just bytes anymore. Now it's actually an account, and the beneficiary is not just bytes. Also, there is actually an account. So we can save that. And then we can also see how the subgraph YAML changes. It's a little bit bigger. Here. So I removed this handle ownership changed, but otherwise it's more or less the same. And then the last step would be the mapping. Also get this. Okay. So this new mapping file, actually, here I created a helper function that says, it basically says like, okay, either we need to create a new address or account in our database, and then I create it, or it's already there, then I just give it back. And then here I say, okay, and when I create a new one, I start with stake 0. That's it. And then, especially the handle deposit, we can quickly look through. So again, we create this deposit entity, and also here the beneficiary, I say like, okay, so either it's first deposit, then we need to create the account, or it's already there. But what I definitely do is like, I take the staked, so we have a staked value on the beneficiary, and we just add the amount staked with this transaction, and then we save. And also with the entity, I renamed it a little bit, so it's sender. So now you see, oh, okay, so this type doesn't exist. When you see stuff like this, usually yarn code gen resolves the problem, because I changed the schema, and because I changed the schema, these auto-generated helper files here, see these are generated, they changed, and then we had like type problems. But now with yarn type gen, code gen, I have them resolved. And actually handle withdraw is more or less straightforward. So we saw this, and then we can just say, okay, like check, does it build? Then we can just deploy again. Cool. And here we check like what's going on. Was it deployed? Not arrived yet. Now when you deploy a new version, first it goes in the pending here. So you also have, you always have kind of the version from before that's around, it's the current version, up to the point that your newly deployed version actually syncs up. It should sync up fairly quickly, but while we're waiting, I can show you another trick. So unfortunately, this playground here, I mean, it's cool, you can do first things, but it has some limitations. So I usually use this GraphQL Online to go directly into to have a little bit more full-fledged GraphQL Explorer. So here, for example, we can say, okay, I want to see the accounts, I want to see the ID and how much it's staked. You can also do skip or word or whatever, and you can click your queries together. So if you're not very familiar with GraphQL or just lazy, this is a very good tool to build your queries. So now we see there's just one staker, and it's staked, I don't know what this, probably 0.1 Ether. Did you just send it? Okay, cool. Do you want to send another one? So now he can send now a new transaction, or kind of can stake more, and then the subgraph will kind of index this after it saw the block, and then we should be able to query this. Here it is. So a subgraph helps you to easily kind of look at certain things on the blockchain, be it a complex DeFi application or being it the bridge to another system like the base ledger. It is an easy way for you to kind of make meaning out of the data from the blockchain and have it ready in this convenient GraphQL interface that you can query. Yeah, I think, let me check. The slides are also here, so if I was maybe nervous, so I just created these. But in the end, you can look through them, and yeah, that's it. Thank you so much. As I said, I'm around the whole weekend, so if you want to use the graph for your project and you have ideas, I'm here. We can brainstorm, whatever. Yeah, thanks for having me.
Thanks for All right, so that's a wrap for this first session. There should be a few kegs here pretty soon. I know everyone's probably excited about that. I know I am. Nah, what? I mean, I don't know. I want a keg. Also, there's catering that's coming. What time is it going to be here? What time it should be? Yeah, in about an hour, and then the keynotes are going to start around 4:15. So, thanks for coming. Good stuff. Cheers, everybody. Welcome to EthAtlanta. This is the third time we've done EthAtlanta. We did EthAtlanta in 2018, and it was a mess. Just ask Ashley. We did it again virtually last year, and it was much better. It was just online because of the pandemic. And this year, I think, is going to be really awesome. The third time we've done it. So, yeah, in 2018. So, to understand the history of why we've had 3 EthAtlantas, you need to really understand the history of Provide. So, I started Provide in 2017 to blockchain enable organizations that really didn't have a clue about blockchain. I wanted to give enterprise developers the same thing that Twilio. I wanted to give enterprise developers blockchain in the same way that Twilio gave those developers SMS, and that largely worked. And in 2018, EthAtlanta, we sort of soft launched Provide there at EthAtlanta that year, and a lot of companies from the Atlanta area came out and tried to build on the stack. I was in the corner fixing bugs all weekend, so that was fun. And somehow Provide managed to survive through the cycles in the markets, in these crypto markets. We made it through a few bear markets. We had just enough customers through that, through 2018, 2019 to keep the company and the dream going. But then they would pay us to build something like a KYC service, for example, and then they would go out of business. And so it was pretty brutal for some years. But we did survive that, and we sort of came out on the other side in mid-2019, sort of thinking hey, you can blockchain enable a developer, but you can't really blockchain enable an enterprise because they don't understand the paradigm yet. And so it was hard. And in mid to late 2019, we decided to really go higher in the value chain with our offering. And what that meant was to create something that could give the enterprise organizations value without them having to learn blockchain or that paradigm in such an in-depth way. And so that's what really led to Shuttle. And I think I started talking with John Wolpert pretty late in 2019, and it turned out that what Shuttle was really the makings of what would become the baseline protocol. So I was really working on the baseline protocol before I knew about the baseline protocol. And that's sort of why Provide has been able to emerge as a leader in that community. As a result of, so I met John through the EEA, and so through the EEA, we created some really awesome relationships, and that includes Unibright. So I met Wolpert and the Unibright guys through the EEA. So we decided that it was a good fit, and we joined the Baseline Protocol community and the technical steering committee, and we developed a relationship with Martin and Stefan of Unibright, and that really became, it was evident that we had a lot of synergies. They had been building no-code style tools, and we'd been building similar things, and they're having the UBT token, as the issuer of the UBT token, it was very obvious to us that there was a good synergy between our stack and their, the token. And so Provide-a-Bright became a thing last year when Provide and Unibright sort of merged the technical stacks under Provide. And we really doubled down on efforts with Concircle and other partners to create this really holistic end-to-end offering for enterprises. That also is the stack that the baseline standard, or the baseline specification that is now pending ratification as an OASIS standard was based. Yeah, so it's pretty exciting. I want to invite Martin and Stefan to join me via Zoom. Can we do that? Hold on just 1 second. Yeah, you guys are coming up. There they are. I see them. I don't see them. They're coming. Oh, they're coming. Oh. Oh!
Hello, hello. We can see you.
There they are.
Obviously.
Okay. Hey, guys.
So, we guess that we are live.
You're live.
If not, somebody has to ping us on one of the available digital channels. Let's assume you're live. So thanks, Kyle.
You're welcome.
You're here as well? Okay, great. So, hello and a warm welcome to Atlanta from the Unified team here in Germany. And not to forget, we heard that there's a bunch of Unified people in the Netherlands watching as well. Finally meeting in person again after 1.5 years. So, hi guys. We are very excited to present here. And yeah, during the next, I guess, around 20 minutes, we will show base ledger at work, meaning enterprise scale baselining powered by UBT and our products that are based on it. Exactly. So as Kyle already mentioned, there's been some history, not only concerning Provide and Unibright growing together, but also in the ecosystem around baseline. So how did we get here? A short history from the Enterprise Ethereum Alliance to Base Ledger from the Provide perspective. We met Kyle in the EEA Integration Task Force 2019, where we just try to answer the question how to synchronize ERP systems by the use of public blockchains. And basically the answer of this integration task force was Baseline, so the protocol initiative for building trust and synchronization of systems using a public blockchain. And I mean, 2020 was a really exciting year. After years of, let's say, pitching a technology, we were finally able to pitch an upcoming solution, a standard. And Base Ledger, so our implementation for real-world enterprises making usage of that baseline concepts was really the step towards adoption that Unibright was aiming for. And together with Provide, we came quite far until now. And internally and also in the community, that's why we refer to ourselves as Provide. And yeah, very happy to be here, and thanks for having us.
Thanks for being here.
Okay. Kyle already mentioned UBT, so the Universal Business Token, and just a short overview how it plays together with all the Unibright products and even former Unibright products, the Provide baseline as a service stack and everything around. So all of the Unibright developments of the last year, they now come together within Base Ledger. All of them require UBT, the Universal Business Token. So just as a short overview, we started with a Unibright framework and our workflow designer in 2017, a graphical tool to abstract blockchain-related complexity. And we will see later that Shuttle, used by Coca-Cola North America, for example, was also inspired by some of the patterns, design patterns, UX patterns, and back-end patterns as well that are that have been established in the workflow designer. Yeah, and then there's of course ConUBC, our Unibright connector, freshly certified by SAP. I guess we'll have a slide on this specifically. And it's a great thing that now finally we have an offering to all sub-customers worldwide via the SAP Marketplace. A standardized way for all SAP customers to connect their ERP systems to Base Ledger and other blockchains and to the Provide stack. That's a huge step. As Stefan said, that's another thing that is powered by UBT, as well as, of course, Base Ledger itself, our public layer 2 or layer 1.5 blockchain, storing proofs, not business data, and rolling up into Ethereum eventually. A solution which comes with some cool key features like low and predictable gas costs, high performance due to its architecture, its data compliance, something that customers are looking for. And we make sure that everything gets open sourced on GitHub. And of course, last but not least, there's Frequency, which allows for tokenization and liquidity concepts and everything around DeFi. We assume that we might hear more from Frequency in the time to come, because it might serve as a backbone for a lot of NFT use cases as well. Non-fungible tokens as well need technical solutions to be minted, hold in wallets, offered, exchanged, and showcased, like, for example, in a museum. And it's something that we are looking into with Frequency. So we have this whole bunch of tools, all powered and driven by UBT, which allow for great enterprise scale blockchain use cases and yeah, baseline concepts at work. Short overview about UBT and Base Ledger itself. There are different levels where UBT plays a role within Base Ledger. First of all, it's a usage voucher for all the tools that we just mentioned, like the ConUBC connector, also the Frequency tools, and of course the complete Provider stack. It's also a stable payment mechanism for network fees inside Base Ledger, and it's also the underlying mechanism for everything that's related to staking and proxy staking. So not only the token which builds and defines the stakes to run the network, but also the mechanism to ensure reward and revenue shares for stakers and proxy stakers. We will come to some of the first findings and some of the first metrics on Base Ledger testnet and UBT and staking metrics later in this presentation. So yeah, the goal together with Provide was, from a customer perspective, to build a complete offering so you can use the baseline pattern within your existing IT system landscape, and at the same time provide a well-balanced ecosystem which is driven by UBT. Okay, some details. I mean, we learned that there had been some great Hackathon Kickoff presentations earlier today already. So you already saw some technical stuff. We will not take it too technical in this keynote, but rather have the high-level view on how customers may use the baseline pattern, or how they implement the baseline pattern, how they can use Base Ledger and the Provider baseline as a service stack. For us, a very vital point here is ConUBC, the freshly SAP certified Unibright connector, which is now available in the SAP marketplace. And I mean, for us, we are coming from an SAP world. We're coming from Germany, and SAP is the market leader in enterprise application software, used by companies of all sizes in all industries. And yeah, funny side fact: 77% of the world's transaction revenue touches an SAP system. So it's
just looked it up.
Very good to start.
Yeah. So I guess the importance of ConUBC is enormous for us. Let's say all companies that are thinking about doing something with blockchain or baselining something, they all have the pain that they need a standardized and compliant way to connect their ERP systems, as they do today when they're connecting to legacy systems or whatever. And now with ConUBC in the SAP marketplace and officially supported by SAP, we have this first initial offering that is just running out of the box and offers a frictionless connection from ERP systems or all SAP systems into the blockchain world. And this is, it's huge. It's the first step. If we don't have this one, then companies just can't on a large scale walk into blockchain. That's our.
And we're working together with Concircle on this. Of course, we We made sure that ConUBC offers native connection to base ledger from the very beginning and to the provided byte stack from the very beginning. I mean, these are the